So our first function that we're going to try graphing is for sine theta. So on your calculator, in y equals, please type 4 sine, and then the variable key is going to call it x because of the mode we're in. Now on your graph, let's see, you guys have what along the x-axis? Those are degrees. What would be other option for measurement of angles besides degrees? Radians. So what mode do you suppose I want your calculator in? In degree mode. So make sure your mode is in degrees. And then we've got a few pre-programmed zooms that would be helpful on this problem, except I want to make sure whatever's on my calculator is going to match whatever's on my paper. So what do you think I want to set up my window as? For my x's, it goes from, let's just say here to here. This is 0, and then what's the farthest out x value? 540. So let's set our x window at 0 to 540. And then what is it counting by? Every square is how many degrees? Can you tell? 45 degrees. And if you didn't set this up, it's not the end of the world, but it does sure help with your pixels. Now for my y's, how low to how high? -6 to 6, good. And what are they counting by? 1s. So now if you go ahead and hit graph, we're going to see something that looks awfully familiar, looks really close to the stuff that we were just looking at on YouTube. So that is called a sine graph. Notice, what is the highest y value do you think you reach on this graph? A 4, and you knew that because your equation, what do we call that number out in front? It's an amplitude of 4. Okay, very good. Okay, what I would like you to do now is just kind of go on a limb and trust me. The sine function started where? Did it start at 0 or did it start up at 4? Started at 0. So it's going to start right here. The next point we're going to graph is at, well, hold on. Let's back up a second. The normal period for a sine function has to do with the unit circle. And what is one full completion of a unit circle? How many degrees? 360. So what I'm going to have you do is take your normal period of 360, and I'm going to have you find what are called quarter points. So take this and divide it by 4. What is 360 divided by 4? 90. So what I'm going to have you do is you're going to mark off every 90 degrees. So 0 is 0, but what would be the next thing we're going to mark? 90. So we're going to have 0, 90, what's next? 180, 270, and then 360. The sine function follows a pattern, and you guys told me he starts at 0. Can you tell off your calculator where he goes next? Does he go up or does he go down? Up. Okay. I'm going to call 0 the midline or the middle. And then the next time we graph a dot, it's going to be on the upper line. And then he goes back to the midline. And then after that, he goes to the lower. And then he comes back to the midline. Now before I start graphing points, I need to have kind of a boundary set in for me. This helps me because you're not going to want to use your calculator in all these. It'll be too tedious. What is the upper line for this graph? What is the amplitude top? 4. So draw yourself a little dashed line. If you want a marker for highlighting, that's fine. And then what's the lowest part? -4. Okay, so midline at 0. The next time I draw a point, it's going to be at 90, and he should be where? Midline, upper, or lower? Upper. Next time I draw a point, it should be at 180. Where should he be? Midline, upper, or lower? Midline. 270 is the next one. Where should he be? Midline, upper, or lower? Lower. And then guess what? The pattern repeats. So middle, upper, middle. What do you suppose I'm going to do with these points? Probably connect them. So do the best job you can. My job's going to be really bad. And it's supposed to be curvy because it's a wave. Now one thing that you're going to add to your foldable is probably what a sine graph just looks like and a cosine graph looks like. You're probably going to end up memorizing it because we're going to do a gazillion of them. But you got to start thinking about things you want to add to your foldable, because you are eventually going to be graphing these for me. And yes, you can use a calculator, but if you are relying on your calculator to graph every single one of these, you're going to have a really tough time, especially when we get to radians. I'm starting off on degrees because I think it's easier for us to divide whole numbers rather than radians. So I know that's probably clear as mud, just move on. Is this your next problem?
Yeah.
Okay. Let's go to this one instead. Number 3. Okay, so talk to me about my amplitude. What is going to be my amplitude in number 3? It's a 2. So first thing I'm going to do is at 2 and at negative 2, I'm going to draw in kind of a boundary line. And of course my center line's at 0. He's smack dab in the middle of it. I measured in degrees again. So the normal period for a sine graph to make one full revolution is 360. But I want you to mark off quarter points for me. So if you take that 360 and cut it by 4, we're going to mark every group of what? What's 360 divided by 4? 90. So you're going to mark something at 0. We always start at 0. And then 90, and then 180, and then 270, and then 360. Now you remember from the last example, sine, where did it start? The upper, the middle, or the lower? Started in the middle. So 0, my first point I'm going to plot is the middle. And then the next time I plot a point, is it going to be upper or lower? Upper. That's the pattern of sine. It goes middle, upper. And then at 180, where am I going to be located? Middle. And then at 270, I'm going to be at lower. And at 360, back to the middle. And then the pattern repeats. And then once you have your points plotted in, just going to connect to make yourself a wave. Okay, let me look around a little bit to see if we have another problem I want to look at first. Oy. Okay. Do me a favor. We're going to do number 2, but we're going to change the problem. I want you to scribble out this 2. I want you to change him so he just says theta. I'm not ready to throw you guys into the deep end yet. What do you suppose is the amplitude of number 2? It's a 3. So I'm going to go ahead and mark off an upper and lower line at 3 and at negative 3. And the normal period is 360. So if I cut that by 4, again, we're going to mark off every 90K. The reason I have to do this quarter point stuff is because sometimes when you guys graph these, I don't provide the graph for you. And it's a little difficult to figure out where you're going to mark things if you don't do this. So we're going to mark at 0, at 90, at 180, at 270, at 360. And it continues from there. But once you graph the first 4, you're pretty much good. Do me a favor, on your calculator, type in 3 cosine of x. And you can leave the window the same that we had for the last problem, and it's going to graph this for you. And I want you to notice one significant difference, besides the fact that the amplitude is a 3 this time. What else do you notice is very, very different? Starts on the upper line. And that's going to be true of every cosine graph. Instead of starting at 0, the midline, he's going to start at the upper line. So, if I go, whoa, get out of there. If I go to 0, you guys just told me I'm supposed to start on the upper. Where did it go after the upper line? It's got to go to the middle line, and then lower, and then middle, and then upper, and then the pattern will continue. So at 0, he starts at the upper line. At 90, uh-oh. What are these counting by? 30s, how annoying. Okay, can you tell where 90 is? Right here. And then 180 is right here, lower. 270 would be right here. And then 360 would be right there. Does it almost seem to you like cosine starts mid-curve almost? It just seems kind of wrong. Again, this is a good thing you want to put on your foldable, is what cosine generally looks like. Starts at the upper and kind of curves down, almost looks like a U. Can't even imagine a worse lesson to be sleeping on and not paying attention. Okay. Let's move on. Go ahead. We're going to come back and do all these problems, so don't freak out. Go ahead to number 7. I want you to look at number 7, please. Three sine theta. So tell me about my amplitude.
3.
So at 3. So we're going to mark off a upper and lower line at 3. Oops. And sine, does that start at middle line or upper line for sine? Sine starts at the middle. Now here's the problem. Look at your x-axis. What is it measuring you by? Uh-oh, it's in radians now. One full complete circle is how many radians? 2 pi radians. So a normal period, which in this case it is a normal one, of 2 pi, we're going to have to cut this into groups of quarters, which means divide by 4. What is 2 pi divided by 4? I don't want a decimal. Pi over 2. So what we're going to do is we're going to mark off every single group of pi over 2. So we're going to start at 0, and then the next pi over 2 would be pi over 2. So this is 1 pi over 2. The next thing would be 2 pi over 2. What is 2 pi over 2? 1 pi. So 1 pi over 2, 2 pi over 2, and then 3 pi over 2, and then 4 pi over 2. But what is 4 pi over 2? 2 pi. Okay, we'll stop there. You guys told me sine was supposed to start at the midline, and then where does he travel after the midline? Upper, and then back down to midline, and then back down to lower, and back up to midline. All right, let's transfer this over. 0, midline. Pi over 2 should be upper. Pi should be back to the midline. 3 pi over 2 should be lower. 2 pi midline. And then if I kind of continue the pattern, I think the next one is 5 pi over 2 is upper. And then 3 pi would be midline. So again, once you have the points plotted, it's not that bad. Okay, pretend. Hopefully yours looks a lot better than mine. Okay, well, you know, as long as it's not jagged and strange. It is a curve, it is a wave. I think we can all agree that radians aren't so exciting because they are fractions. But I'm kind of here to deliver some bad news to you. All your problems on your homework and your assessments will be in radians because they never really graph in degrees for Algebra 2 and for trig. It's always in radians. I wish it wasn't the case, but I started you guys off with degrees so you could see the division a little easier. All right. There's nothing here that just has like a plain cosine, right? No. All right. Go back to the first one we skipped, which was number 4. Okay. There's something very, very strange about number 4. Something I haven't told you about yet. Can you pinpoint what it is? The theta is being divided by a 2. What that means is we've adjusted our period length. The frequency is different. What's inside the sine function tells you how much of a cycle you will complete in one period. So instead of completing a full cycle, which would have been a 1 theta, we're only going to complete a half cycle. Okay. I'm going to give you guys a very systematic approach to this. I don't really want you guys to have to memorize too much, and that's why I've given you a foldable. So take some really good notes right now so you can transfer this stuff to your foldable later. What you have here is a trig function in the form a, whoops, that's not b, times the sine of bx. Your period for any trig function is going to be what a normal period is. So if we're in degrees, it'd be 360, and you would divide it by whatever your b value is. So be careful. Our period is normally 360 in degrees for sine, but I'm going to divide it by the b value. Can anyone tell me what the b value is here? It's a 1/2, because it's a 1/2 theta. Do you agree? I know it's divided by 2, but that means it's times a 1/2. What would happen if you took 360 and divided it by 1/2? If you're using your calculator, either type 0.5 or make sure 1/2 is in parentheses. You get 720. What that means is it's going to take 720 degrees for this wave to complete one cycle. Okay, now I'm going to have you guys mark what's called a quarter point. Just kind of like what we did in the easier examples. My quarter point would be taking my entire period and dividing it by 4 quarters. What am I going to mark by? 180. So every 180, I'm going to mark off one of my points. So you always start at 0, and then the next group is 180. What would come after that? 360. And then what's another group of 180? 540. And then 720. Can someone look back at a previous problem and tell me how a sine cycle works? He starts at midline, and then he travels to the upper, back to midline, lower, back to midline. Okay, we almost have everything we need to graph this. One more thing I need to do is mark off my amplitude. So it looks like he's an amplitude of 2. All right, now for the fun part. Midline, 0. 180 is upper. 360 is midline. 540 is lower. 720 is midline. Can you kind of continue the process now without having to calculate anything more? I think 900 would be upper. And then 1080, is that 1080, would be middle. The good news about the graphs is they're very symmetric and they're very patterned. So once you kind of have a sense of what's going on, they're not too bad. Whew. Okay, long time ago, I told you that this 1/2 meant that your sine function would only complete half of a cycle by the time it got to 2 pi, or 360. Here's 360 right here. Did it only complete 1/2 of a cycle? Yeah. That's exactly what that b value indicates, how much of a curve you're going to have by the time you get to one whole cycle, which is 2 pi or 360. Okay, let's look at number 5 now. Let's at least get the easy part in. The amplitude is 3. Your b value. What is your b value? 1/2 again. So what we're going to do is we're going to take our normal period, which for degrees is 360. We're going to divide it by the b value. And what's the new period for this new function? 720. We already kind of did this problem. Now, if you go ahead and cut it by 4s, you get 180 markings, 180 group markings. So we're going to start at 0. Hey, it's very similar to the last problem. Sine, where does it start? Middle or upper? Middle. So middle, upper, middle, lower, middle. Okay. And then once you get to 720, hopefully you have enough to kind of continue the pattern. Whoops. Okay. Let's try getting one more together. Okay, cosine. What is the normal period for cosine if it's in degrees? It's still one full circle, which is 360. And then we're going to divide it by your b value. What is your b value? 1/3. So what is 360 divided by 1/3? Use parentheses. 1080, okay. That's your new period. It's going to take 1080 degrees. But, whoa, sorry. That's not helpful for me because I need to know where to mark. So I'm going to cut this into quarters. What is 1080 cut into quarters? 270, okay. So I'm going to mark at 0. I'm going to mark at 270. When's the next marking? What's 270 plus another 270? 540. And then 8 to 10. And then 1080. Okay. Where did cosine start? Upper. And then he travels down to middle. Then he goes to lower. Then he comes back to middle. And then he goes back to upper. Okay, let's mark in our amplitude of 2. Oh, jeepers. 0, we should start at the upper line. Okay, can you tell where 270 is? What are these guys counting by? Looks like they're counting by 180s. So I think 180 and 360, right smack dab in the middle of them is 270. Do you agree with that? Yeah. Okay. 540. Okay, what's 360 plus 180? 540, right? So 540 should be lower. This is the unfortunate part of them providing the graph. Sometimes it doesn't quite fit. 810, I believe, is smack dab in the middle of these two. And then 1080 is up here. So it looks like we're traveling 1.5 units every time. So we'll travel 1.5 units down to here. Okay. And then when you connect your points, you kind of get this weird, funky, oh geez, that's terrible. Okay, oh, that's really bad. Okay. What I want for you guys tonight is to start your homework.